Extra, extra, read all about it. It's all over the news, and today it's our front page headline. It's out with the old, in with the new, and the quadratic formula is taking the world by storm. More on page 7. Today, let's get right into that cover story and continue with our discussion of our titular quadratic formula. You'll recall from the last time that we chatted, we derived by completing the square the handy-dandy quadratic formula, which tells us for a quadratic equation in standard form, ax squared plus bx plus c equals 0. There is a particular relationship among its coefficients that allows me to identify the general form of its solutions without fail. Take 10 seconds, look back at those notes. What is this relationship here? How can I write the solutions to any quadratic equation in standard form? Go! Alrighty, we want to commit this bad boy to memory, so let's say it together. We know from the quadratic formula that the values of x, or any variable depending on our specific equation, will be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, it's one thing to know this formula, which is important, but even more important is making sure we know how to use it. So since we've refreshed our memory on the what, let's refresh our memory on that how. I want to solve for x in the following equation, x squared plus 3x minus 10 equals 0. Let's get some practice using our quadratic formula. Take 2 minutes, solve for x. Let's do it. Go! And stop. Well, I know here from my quadratic formula that x should be equal to, say it with me, negative b plus or minus the square root of b squared minus 4ac all over 2a. As long as I can identify the values of a, b, and c, I should be home free. Well, a is just my leading coefficient, which here is invisible 1. B is the middle coefficient, which here is 3, and C is the constant term of negative 10 at the back. All I need to do now is substitute into my quadratic formula. Well, negative B would become negative 3, plus or minus the square root of B squared, which would be 3 squared, minus 4 times A, which is 1, times C, which is negative 10, all over 2 times A, which here is 1. From here, I just need to simplify the right-hand side, and in so doing, I will reveal the values of my variable x. So, negative 3, can't do much with that, but I can simplify the stuff inside that square root. Well, 3 squared is equal to 9. Negative 4 times 1 times negative 10 should get me positive 40, all over 2 times 1, which is 2. So negative 3 plus or minus the square root of 9 plus 40 would become the square root of 49. And hey, I know how to take the square root of 49. That is 7. So I've got negative 3 plus or minus 7. Notice that negative 3 and 7 can indeed be added and subtracted together, which tells me, just like we saw in class last time, that I want to do some splittage. So from here, my two cases, either negative 3 plus 7 over 2 could be my value of x, or negative 3 minus 7 over 2 could be my value of x. Simplifying the one on the left, well, negative 3 plus 7 is positive 4, and 4 divided by 2 tells me that x equals 2 is my first possible value of x. Negative 3 minus 7 over on the right is negative 10, and negative 10 divided by 2, x equals negative 5, should be my second solution. If I want to be really annoying, I can of course write this in set builder notation. Negative 5 is smaller than 2, so it comes first. This will be the only equation that I write it in this form for, but again, that option is always available to me should I so choose. From here, let's do some more practice. I want to solve for n in this case, 0 equals 3n squared plus 2n minus 3. Again, because of the specifics of this equation, I might want to make a slight change to my quadratic formula, but the process should be more or less the same. Take 2 minutes, take a risk, take a chance, go find me some values of n. Go! Alrighty, you're too far gone. Let's come back. So I know here that n, rather than x, because n is my specific variable, should be equal to negative b plus or minus the square root of b squared minus 4ac all over 2 times a. In this particular equation above, I just need to find my values of a, b, and c. Well, a at the front is 3, b in the middle is 2, and c at the back is negative 3. Let's do some substitution and solve for n. So n is going to be equal to negative b, which is 2, plus or minus the square root of b squared, which would be 2 squared, minus 4 times 3 for a, times negative 3 for c, all over 2 times 3 for a. From here, let's simplify that stuff on the right. Well, I've got negative 2 plus or minus the square root of 2 squared, which is 4. Negative 4 times 3 is negative 12. Times negative 3 should get me positive 36, all over 2 times 3, which is 6. Negative 2 I can't do much with, but inside of those square roots, right, I can always combine some like terms. 4 plus 36 is 40. And if I'm thinking strategically, inside of the square root of 40, right, I can simplify further. Notice that 40 is 4 times 10. And while 10 can't be square rooted, the 4 certainly can. So I'm going to use my properties of radicals to rewrite this as negative 2 plus or minus the square root of 4 times the square root of 10 all over 6. So I've got negative 2 plus or minus the square root of 4, which I know is 2. Smush that right back up against the root 10, all of this over 6. And now one last thing stands between me and my final answer. Notice, wherever I can simplify, I should. 2, 2, and 6 are all even, which means that they can all be divided by 2. Simplifying as much as I can reveals here that n should be equal to negative 1 plus or minus the square root of 10 all over 3. Very nice. Let's do another. Here, I want to solve for t when 2t squared minus 7 equals 2t. Now, something about this equation is a little bit different from the previous two that we solved. What is it, and what does it need to look like if, thinking strategically, I want to use my quadratic formula? Take a minute, try it out, and then come back. Go. Alrighty, well, once again, the quadratic formula only works if my equation is in standard form. So I need to use my mathematical superpowers here and make this look the way that I want it to look. In order to write it in standard form, I've got to get a 0 on one side. Well, the easiest way to do that would be to subtract 2t from both sides. So I've got 2t squared minus 2t minus 7 in standard form is equal to 0. And now, using my quadratic formula, I should be able to identify my values of t. Say it with me. T equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, a, my leading coefficient here, is 2. B, my middle coefficient, is negative 2. And c at the back is negative 7. Let's slot everything into place. This tells me that t should be equal to negative b, which is negative 2, plus or minus the square root of negative 2 for b squared, minus 4 times 2 times negative 7, all over 2 times a, which is 2. Simplifying over here, I've got negative negative 2, which is a fancy way to say positive 2, plus or minus the square root of negative 2 squared, which is 4. Negative 4 times 2 is negative 8, times negative 7 is positive 56, all over 2 times 2, which is 4. From here, I've got 2 plus or minus the square root of 60 over 4. And once again, I should take that 60 and see if I can find any factors that are perfect squares. Once again, 60 is a multiple of 4. In this case, 4 times 15. So using my properties of radicals, I'm going to split this guy up. The square root of 60 equals the square root of 4 times the square root of 15, which can be simplified further to 2 plus or minus 2 root 15 over 4. And just like above, notice that all of these numbers are even. I can divide them by 2. So I'm left in my fully simplified form with a final answer of t equals 1 plus or minus the square root of 15 all over 2. Lovely. 2 more for the road, and then we're free. Let's try it again for w here. 6w squared plus 10w equals 5 minus 3w. Again, I need to rewrite this in standard form, and then I'll use my quadratic formula to find some values for my variable. Go, go! And stop. So from here, I don't really care which side I move everything over to. Because the w squared is already on the right, I'll move everything, or on the left, sorry, I'll move everything over to the left as well. So I've got 6w squared plus 13w is equal to 5. Now subtracting 5 from both sides to get my 0 on the right. 6w squared plus 13w minus 5 is equal to 0. Now, using my quadratic formula, this tells me that w should be equal to, once again, negative b plus or minus the square root of b squared minus 4ac all over 2a. In this equation here, I need to find my values of a, b, and c. At the front, my value of a is 6. In the middle, my b is 13. And c at the back is negative 5. Slotting everything into place, let's solve for b. So w should be equal to negative 13 plus or minus the square root of 13 squared minus 4 times 6 times negative 5 all over 2 times 6. Simplifying on that right-hand side, I've got negative 13 plus or minus the square root of 13 squared, which is 169. Negative 4 times 6 is negative 24. Negative 24 times negative 5 is positive 120. All of this over 2 times 6, which is 12. So, inside of my square root, I'm left with negative 13 plus or minus the square root of 289 over 12. And though I might not know it off the top of my head, 289 is in fact a perfect square. It is 17 times 17. Now notice, 13 and 17 are like terms. I can combine them, which means just like above, I want to split this into my two cases and go as far as I can. So I've got negative 13 plus 17 over 12 and negative 13 minus 17 over 12 as my two options. Well, negative 13 plus 17 over on the left is positive 4. And 4 over 12, both of those are divisible by 4. That leaves me with 1/3 as my first possible value for w. And over on the right, negative 13 minus 17 is negative 30. And 30 and 12 are both divisible by 6. 30 divided by 6 is 5. 12 divided by 6 is 2. I've got my negative sign out in the front. And here is my second value of w. One last one for the road. Let's try it out with this guy. Negative 3 times parentheses 2k minus 5 equals 9k squared minus 15. Take a risk, take a chance, take a couple minutes and see if there's anything strategic that you might be able to do before you plug into your quadratic formula. Go! Alrighty, let's come back together. So my first move should be pretty clear. Just like before, when I was working with factoring, when I was working with zero property, I want to get rid of parentheses before I solve. So I'm going to begin by distributing this negative 3. Negative 6k from negative 3 times 2k. Positive 15 from negative 3 times negative 5 should be equal to 9k squared minus 15. From here, I need to move everything over to one side. I'm going to choose here to move everything to the right, but again, it does not necessarily matter. Adding 6k to both sides first, I've got 15 is equal to 9k squared plus 6k minus 15. And last but not least, subtracting 15 from both sides, negative 15 minus 15 is negative 30. Now that I'm here, I have the opportunity to make a strategic decision. I could substitute into my quadratic formula just fine, but look at 9, 6, and negative 30. What can you tell me about all three of those numbers that I could maybe use to make my life a little bit easier? 10 seconds, go. 5, 4, 3, 2, 1, and stop. Well, notice that 9, 6, and 30 are all multiples of 3. So as a quality of life choice here, I'm going to divide my entire equation by 3. On the left, 0 divided by 3 is just 0. 9k squared divided by 3 leaves me with 3k squared. 6k divided by 3 leaves me with 2k. And negative 30 divided by 3 is negative 10. Now, I didn't need to do this, but as I plug into my quadratic formula, which tells me, of course, that, say it with me, negative b plus or minus the square root of b squared minus 4ac over 2a, really beating this horse to death. Right now I have much friendlier numbers to plug in. So I've got an a value of 3, which is much nicer than 9. I've got a b value of 2, which is much nicer than 6, and a c value of negative 10, which is way nicer than negative 30. Subbing everything into place, let's bring it home. I've got negative 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 10 all over 2 times 3. Well, negative 2 over there can stay as it is. Plus or minus the square root of 2 squared is 4. Negative 4 times 3 is negative 12. Negative 12 times negative 10 is positive 120. And 2 times 3 is equal to 6. From here, I can simplify inside of my square root. This is negative 2 plus or minus 124 over 6. Now, inside of 124, once again, I want to look for any perfect squares. Now, I know that 124 is going to be equal to 4 times something, in this case 4 times 31. So same move as before, I'm going to split this guy up. Negative 2 plus or minus the square root of 4 times the square root of 31 using my properties of radicals, which is going to reduce to negative 2 plus or minus 2 root 31 all over 6. And for my final act, let's divide all of our numbers here, all of those even numbers, by 2 to reveal our final solution of k equals negative 1 plus or minus the square root of 31 all over not 6, but 3.